Assalamu alaikum. In the previous lecture, we have started talking about the soil formation factors, how the soil is formed from 5 different factors. We abbreviate them into seaports. And we have said that all of these factors act at the soil at the same time. We have seen the effect of parent materials and organisms. And in today's lecture, we would focus more on the effect of topography or relief and climate and the time. Without further ado, let's begin. Well, one of the most important factors that affect the formation of soil is the effect of topography. I mean, the change in the slope or in the topography, the elevation. So what happens that here, there are several factors that we have to consider. One of them is the slope and aspect. The other things is how the parent materials and the topography interact and the soil build up. Let's start with the slope aspect, which is basically like demonstrated here. So with the mountain, there will be some areas at the faces that would face the sun for most of the time. And these areas would be subjected to more heat and the evaporation, there will be more evaporation from it, and it will actually affect the biochemical reactions and the development here, and also the vegetation cover than the other side, which receive less solar radiation. Also the effect of topography, because when we have a topography, a change in the topography from top to the bottom, there is actually a slope, and with this slope there will be a formation of different parent material, as you would see in the coming slides. Not only that, but some of the things which receive when rain happens, some of the materials will be washed out from here with the slope, run over the surface, or come from the bottom, and then it will be deposited somewhere here in the flat surface at the bottom of the slope, like salts. And you would see more details as follow. So if we look at the topography, the land, there is actually a different position. So if you look at it, we have actually, or we call it at the top here, we call it the summit. And then you have a slope. And then at the end, you have like a curve down, which actually collect everything. So what happens that the flat area at the top, we call it summit. Then you have shoulder. Then you have back slope here. And then you have teo slope. And finally, you have the flood plain. Now, how these different places or positions affect the water movement and the development of the soil and the vegetation and the parent material and everything. Well, as you can see that when you have a mountain or a topography like this, the areas at the top which receive when rainfall happens, like most of the rain actually enter in these areas. And what happens that these, like the physical and the chemical weathering work or act on the rock, and then they help formation of the soils. Then the impact of vegetation and the type of vegetation, that would actually create a different type of soil than the other areas. Now, if we look at the area here, like the back slope, which is at a slopey, very sharp slope, what happens that in this area, you will see the soil is very shallow. Why? Because as water run over the surface, it actually, or as rainfall happens, what happens that water always run over the surface because it doesn't find enough time for the water to infiltrate down, and therefore it erodes most of the soil, and you have very shallow soil. Now, what happens that the soil which is eroded from this area would be deposited here at the bottom, at the toe slope. Of course, there's a floodplain there. So now when the things deposit here or start deposit here, you would have different layer and different soil, as you can observe. Not only that, but there is actually an interaction between the topography and the parent material. If we look at the summit, you would find most of the parent material that exist here are residual. Why? Because this is a flat area, and once the plant, for example, or the materials here fall, the organic material fall, it decomposes, and then it will be formed in a place. Also, there will be some disintegration of the rocks from the bottom here to form residual soil. If you look at the area at the back slope and the toe slope, most of the things which here happen is actually colloidal parent material. Why? Because there will be an effect of the gravity forming these types of the soil. Once the water comes, rainfall, valley, or other things, it will actually erode the materials from here and deposit it somewhere here at the bottom at the floodplain. And you would find that most of the soil that here would classify it as alluvial parent material because it actually received from above. Now, when we discussed about the effect of climate, we have to consider three different things. Number one is basically the effect of precipitation. And also, actually, secondly, the distribution of this precipitation. I mean, how it is distributed. And then the effect of temperature. When we talk about precipitation, we have to understand that the water would be more effective, or the precipitation will be more effective if it's actually enter deeper into the soil. So as it go deeper into the soil and create changes in the soil, this we call it an effective precipitation. Whereas if the precipitation did not enter deeper into the soil and created changes, then this will not be very effective. So effective precipitation is that the water has to penetrate deeper into the soil, move things like release minerals, create changes, and this we call it effective. The temperature also has an effect on the biochemical reactions, as you would see, and also it will affect the microbial, or let's say the biotic community. And one very important thing, that the past and the current climate affect also the development of the soil, because you might have areas where in the past were used to be tropical areas, but now they are desert and so on and so on. So the climate that was in the past would affect the development of the soil and even the current climate. Now, when we talk about temperature, the temperature actually actually increases the chemical reaction or the biochemical reaction. So it means that if there is a 10-degree increase in temperature, the chemical or the biochemical reaction double. Also, it has an effect on the microbial growth and the microbial decomposition. And we have seen from the past that if the temperature is warm and you have abundance of moisture content, then you're actually maximizing the weathering, the leaching, and also the plant growth. Not only that, but the type of climate can affect what type of plant would exist in the area. For example, if you have a climate that is humid, then it favors the growth of trees like forest. If the climate is subhumid and semi-arid, then it favors the growth of grassland. Whereas if the climate is arid, then you would have actually shrubs and bushes. Why? Because the amount of moisture content that exists in the area and the temperature would actually affect the growth of the plant, and also it will affect the soil itself. Now, when we talk about effective precipitation, again, I'm reminding you, effective precipitation means that the water has to infiltrate and go down into the soil. If it goes down more, then it creates deeper changes, and this is, we call it effective. Now, we can compare the effective precipitation in terms of 4 different aspects: the distribution, the slope, evaporation and plant use, and the soil texture. Let's start with the distribution. Look here, what you can see here, you see soil, a profile of soil, and the arrow here describing how much water is used for plant or evaporated or go down into the soil. So if the arrow is thicker and going deeper, it means that it is more effective. It means that more water infiltrates into the soil. So if we assume that a rainfall of amount, let's say of amount 200 millimeter per year, distributed every month. So let's say that, or let's say 120. Let's assume that the precipitation is 120. So if you divide 120 by 12, then you would receive every month 10 milligram per month, 10 millimeter per month. Now imagine if you receive this amount of water. It is not enough to go deeper into the soil. Keep in mind that some would evaporate and some would be used by the plant. If you compare the situation where this 120 is just fall like 2 times per year, so each time is 60 millimeter, this amount of water would be now much to infiltrate more into the soil, and therefore it will be more effective. Now, let's go to the second scenario where you have actually evaporation and plant use. Now, let's assume if the evaporation is very high in the area and the plant uses much of the water, then there will be less water going down into the soil, and therefore this condition would not be effective as compared to a condition where you have like most of the water going down because the evaporation and the plant use is less. Now, if we look at the effect of the slope, if you have an area that is flat, the flat area, would actually most of the water would fall, some of it will evaporate and will be used by the plant. In the slopey area, some of the water would also run over the surface, and this would reduce the amount of water that goes down into the soil. In the area at the floodplain, which actually curve down, most of the water which actually run over the surface from here will be collected here. And this, because of the curvature of this area, most of the water would actually go down into the soil. So this condition would be more effective. Now, if we discuss the effect of the soil texture, we can say that if you have a coarser soil texture, which means have larger pore spaces in the soil, then most of the water would go down into the soil, would be more effective condition as you compare to a clay where the pore spaces are very fine. And then in this condition, some of the water would run over the surface and you would have less water going down. So this is described in a simple way how precipitation become effective depending on different factors. Now, if we think about the time is also another factor which actually affect the development of the soil. The longer the time you give for the factors to interact and act on the soil, the more the development will be. Let's assume that you have a warm climate, a warm, humid climate. In this condition, we are showing the time scale from 0 year to 100,000 of years. So what happens that at the beginning you have rock, and then all the conditions, the soil formation factors act on this rock, and therefore it starts to develop very thin soil. With time, you will have a layer of soil and you start developing some of the vegetation. Now, assume that the vegetation grow and then you have seeds, and then the soil become deeper and deeper and deeper with time because this rock is weathered. The vegetation act on it and the roots, and the start to development of some of the forest trees because the climate is good to allow forests to grow and the soil is now becoming good. Now, what happens that with time, all of these factors play or act on the soil, leading to developing very deep soil. And as you can see here, that with time you have different letters here, A, C, R, A, E, B. These are indicating the development of soil, and we will discuss it more in the coming lectures, which we call them actually the soil horizon. So to develop the soil, you need actually longer time, and you need favorable conditions of the soil formation factors. But something very important that I want you always to remember, that you cannot separate the soil formation factors. All the factors are happening at the same time on the soil, leading the development. But the degree of the weathering and the degree of the development would differ from one place to another because of the differences in the factors. I think this is the end of today's lecture, and I would leave you now with a break that summarizes for you everything. I hope that you enjoyed the lecture, and see you in the discussion session. Bye.
Soil is so much more than just dirt. We all depend on soil as the lifeblood of agriculture, and people around the world from small backyard gardeners to large industrial farmers, rely on soil to make a living. In fact, most terrestrial ecosystems rely on soil as the giver of life. Let's learn more about this vital stuff, soil. Soil is the topmost layer of Earth, lying on top of a layer of bedrock. Soil is often black or dark brown to red, comprised of mixture of organic remains, clay, and rock particles. Most soils support a thriving community of microorganisms and invertebrates, aiding the breakdown of organic matter in which plants grow. There are many types of soils throughout the world. Different regions and ecosystems have characteristic soils. Scientists have classified soil types according to their characteristics. The soil orders differ in color, texture, nutrient content, water holding capacity, and soil biota. Oxasols, one of the soil orders, typically develop along the tropical and subtropical latitudes, including rainforests in South America and Africa. Aridosols develop in very dry environments, notably the deserts of the United States Southwest, North Africa, and Western Australia. All soil formation begins with the breakdown of rock or parent material over time. Rocks can be broken down by mechanical weathering, such as frost or rain, or cycles of heating and cooling. Fragments of rocks are often transported by wind, ice, or water. Soils form where the products of weathering and erosion collect. Alluvial soils form at the mouths of rivers where soil is deposited by water. As the current slows, suspended solids settle, and when the water recedes, it leaves behind a mixture of stones and silt, which can be colonized by plants and animals. Aeolian soils, like these dunes, are created by wind depositing well-sorted particles of sand. Aeolian soils can form anywhere that drifting particles might collect, such as along beach areas. The parent material determines the chemical composition, properties, and nutrient content of soils. For example, soil formed from a parent rock of limestone will be rich in calcium carbonate, be basic, and have a high pH. Mollisols are created from limestone and commonly support grassland environments, such as savanna ecosystems. Soils created from the parent rock of volcanic eruptions are called andisols. Volcanic ash contains all the minerals plants need to grow, so andisols are typically some of the most fertile soils on the planet. As the parent material weathers, particle size decreases. The particle size of the soil determines its ability to retain and drain water. Since plants depend on water, soil particle size strongly influences the soil's ability to support plant life. Clay soils have small particles and drain slowly. Sandy soils have larger particles and drain quickly. The amount of water a soil retains in turn helps determine its chemical properties and temperature. The specific amount of water in a soil at a given time is affected by two soil-forming factors, climate and the topography. Climate directly determines the temperature and water content of soil throughout the year. Exposure to the sun will increase soil temperatures and may speed up chemical and biological processes that occur in them. Grassland soils in a prairie or savanna are relatively dry because of the lack of rain. Soils in an equatorial or boreal climate are usually moist because of the wetter climate. Topography refers to the variation of the landscape. The topography of a region can also determine how much water is present in a soil. Soils on slopes tend to be well drained. Soils in hollows or low-lying areas are wetter and can become waterlogged and anaerobic. Time is perhaps the most important factor determining the nature of a soil. Over time, parent materials weather into smaller and smaller particles. Various organisms colonize and live on and in the soil. As soils develop, they continue to be altered by a succession of different organisms. The biota that calls the soil home. The biota affects soil formation through the addition and recycling of organic matter, alteration of its biochemical properties, and the retention of nutrients. Humans are a part of the biota that alter soil as well. Humans clear cut forests, plant crops, use fertilizers and pesticides. All of these practices disturb the soil, altering its chemical makeup and making it less fertile. We all depend on soil, a vital natural resource. Agricultural companies, farmers, developers, and legislators must work together to understand the risk of losing soil and to improve the agricultural practices needed to protect it.